I'm going over a couple of questions from the XYZ homework number 4. This is number 16, but it's really similar to 13, 14, and 15. So this should help you with all of those. So if you've been having some trouble with those, this should help. So first thing I noticed about this is that the equation is written in a form that we don't like, because the frequency is kind of is factored through or distributed through the phase shift. So first thing we want to do is rewrite this as 4, 10, and I'm going to factor out that 2. So now we can see clearly that's my vertical shift right there. That's my that is my phase shift, and that is, in this case we're not going to worry about the vertical shift, doesn't really come into play, but anyway. So now we can answer the questions. The first question, A, says the stretching factor. Now that's a little bit unclear because you could stretch it vertically or horizontally, but when they say stretching factor, they mean the vertical stretch factor. And that would just, of course, be the number out front, which would be 4. This part B says the period, and we all know that the period is equal, because it's tangent, it'd be pi divided by the frequency, and there's the frequency right there. So the period is, now, and then I'll skip down to the range. The range is just all the possible y values. And since this is tangent, and we know tangent goes like that forever, we know that this is just all real numbers, so you'd put a negative infinity would be the answer for the range. And then, so finally, this is the part that people are probably having trouble with, is the C and the D. Now, first thing you understand is these are the same, because when the domain is, says the domain, and this stands for all x's except for the ones that aren't right. And so, of course, where the domain is missing a spot, that's where the asymptotes are. So these are really asking the same question. Where are the asymptotes? It's asking down here. Up here, it's asking where is the domain missing, where's a hole in the domain, and that's where the asymptotes are. So what we're going to do is we're going to start, first of all, with what tangent looks like. We all know that one cycle of it looks like this, and that's negative pi over 2. And of course, it repeats itself. Okay? But of course, these numbers up here are going to change what that looks like. So what we want to do is draw a picture of the new. And we're basically going to look at this one cycle and see where it goes. Now, the first thing I'm going to do is, I notice that everything's moved to the right 2, which means this point right here is going to move to the right 2. Let me grab a highlighter. This becomes a very important point because it's not affected by the change in period, because it starts out on the y-axis. Any horizontal stretching is not going to affect that point. So I know that this point is only moved by the phase shift and the vertical shift. We don't care right now about the vertical shift because they're not asking us about that. So we know that this thing is going to be moved 2 to the right. So that means this point that was the flat spot is now over here 1, 2 to the right. So that's where the new, so that the green spot there is now out here at 2. Okay? Now, the next thing that changes stuff is, of course, we know that the asymptotes are a little bit left of that and a little bit to the right of that. So that we know the new thing looks something like this. The question is, where are those asymptotes at? And of course, that's affected by the period. We know the period is pi over 2 long. That means the total cycle takes pi over 2 to complete. And since we know that this green dot is in the middle of that cycle, we know that this distance right here would be half the period, or pi over 4. And this distance right here would also be half the period, or pi over 4. So since this right here is 2, this spot right there would be 2 plus, and that spot right there. And so now we know where the asymptotes are. And remember, that's what this is asking for. So now I'm just going to go up and fill this in. Now, even if you could come up with that picture, it's still kind of hard to figure out what XYZ wants here, and that's one of the reasons I made this video, is the way they want you to do it is they want you to fill in, basically they want you to find out where the thing that was at the origin moved, and we know that that moved to 2. So we're going to put a 2 there. And then from that, you're going to tell it how to get to the asymptotes. Because remember, we're trying to tell it where the asymptotes are. Well, we know if you go pi over 4 to the right, you're going to hit an asymptote. So I'm going to stick a little pi over 4 in there. Pi over 4 to the left, I would also hit an asymptote. But if I go 2 pi over 4, so there's a second pi over 4, I'm going to hit the middle line, right? Because the middle line's right here again. So from there, I'd have to go pi over 4. Then I'd have to go 3 pi over 4 to hit the next asymptote. So that's why up in here, there's a drop-down menu. I'm going to pick odd integers. Because that way I'm going to start at 2, and I can add pi over 4 to it to get this one. I can add 3 pi over 4 to it to get this one. I could add 5 pi over 4 to get the next one out here somewhere. I could add 7 pi over 4 to it to get way out here, and so etc. And then, of course, if that's the right answer for this one, it would also be the right answer for integers. Okay, hopefully that was helpful. I just want to make a quick one. Let me know if you have questions. Email me. Thanks.